Hey guys, welcome to today's is Tuesday. It's the second day of our unit, second day of quarter three. We're starting today. We're going to talk about puzzle and fossil evidence for an idea. So first of all, I want you to think about what do you look for when you put together a jigsaw puzzle? What are you looking for? You be prepared to tell me in Pear Deck or looking at the live. You missed live class. You're looking at the video. Answer right on the slide for me. Remember that if you miss class, like you might have, which is why you're watching the video, check Google Classroom, reach out to me, reach out to your teacher to make sure that you are communicating and find out what you missed. All right, so after our science of the day, I'm going to introduce you to our new unit. I'm going to show you what the activities were in the breakout rooms, and then we're going to jump into some independent work. This is Dr. Marcela Nunez Smith. She recently made the news, and I'll tell you why in a second. So she grew up in the U.S. Virgin Islands, so that's in the Caribbean. Although she's a U.S. citizen, those are U.S. territories. She is a professor of medicine and epidemiology at Yale. And she's also the Dean for Health Equity Research and founding director of the Equity Research and Innovation Center. So she's all about medicine, epidemiology, but also about equity and how can we study epidemics and study disease and how it affects different groups differently, but arrange outcomes, plan for outcomes to make it more equitable. And specifically about trying to get more diverse candidates into medical school, fewer just white men and more people of color and women as well. So she was nominated as a co-chair, and she actually just started today. So I'm filming this on January 20th, inauguration day. And so as of today, when I'm filming this, she is in. So she's not necessarily nominated. She now is. I'm actually going to change this. She is now co-chair of Joe Biden's COVID-19 advisors. I think it's advisory board. Let's call it. I think it's called an advisory board. So it's a bunch of different doctors and health officials from across the country that meet and look at data, come up with recommendations, and give them directly to President Biden. Let's put that in here too. President Biden. That happened today. So she's actually the co-chairs, two chairs of that. So she has an enormous influence on national policy at this point because she has the ear of the president, which is pretty cool. Today we are starting Unit 4. We actually kind of started yesterday. I asked you a bunch of questions about different earth science topics yesterday, like volcanoes and canyons. I love this image that I found. This unit is kind of be broken into kind of three pieces. There's three standards. The first one that we're starting now is evidence for continental drift. It'll only take us about a week. The bigger standard is going to be about how Earth processes change the surface of the Earth. That would be things like volcanoes, mountains, valleys and lakes and canyons. How did all those things even become a thing? Where'd they come from? We'll talk about that. And then kind of building on that, we're going to be looking at minerals, energy, that being like oil and natural gas, groundwater, how they're not distributed equally. Like there's not equal amounts of oil all over the earth. They're kind of in specific locations. How did that happen? We're going to spend about a week learning about that as well. First things first, I'm going to move myself out of the way here. I actually asked some students to pair deck with me and label, since we're talking about continents. I want to know, do you know which continents are which? If not, that's okay. That's why we're here to learn. So let's do that. I want you to label, use these words over here. The oceans, there are 5 oceans, there are 7 continents. Label them on this map, please, and thank you. We're going to do an activity. We did an activity in breakout rooms that you missed, so I'm going to just talk about it real quick. We're going to be looking at continent shapes and fossils. And now these are the general colors of the different fossils we're looking at. And just generally, I want you to know what these are. So this is actually a picture of a Glossopteris fossil that have been found in different locations on different continents all around the world. This is one example of 2 Mesosaurus. I actually haven't said that word out loud. Which are kind of a unique um, um, dinosaur. Is it a dinosaur? It says Osar. It exists about 240 million years ago. So I would say it's around the time of the dinosaurs at least. And they also are found on different continents, which is weird. This is the head of a Cynognanthus. I should not be a paleontologist, or I should so I could learn how to say. I labeled these pink. It says orange here, but those are pink on your fossil, on your puzzle. They're also, this is the skull of one, obviously. It's pretty crazy looking. They were also found, these fossils, on different continents, which is like, how did they get between the continents? Did they swim between the continents? Did they run and jump? How would a plants can't swim and jump. How would they get between the different continents? So more on that. So these are just the directions. So here's your puzzle. These are puzzle pieces. If you move them around, you can see that you can kind of see through them, which is maybe a problem, but you'll be okay. You're gonna have to move them around, and if you find right here, I don't know of an easier way to do this. Maybe here. Oh, that just resets it. Okay. So what you can do is find this little, you see the border, there's a little ball like at the bottom, and if you click on that, you can then move your mouse and as you move your mouse in a circle, it'll rotate, and you can rotate it in a circle. And your goal is to get all of these things to touch each other and match each other. And if you need a hint, then I would specifically look at the fossils. Look at these fossils. How do the fossils fit together? And use that to help you fit all these continents together. Okay, they're not really fitting on my slide super well. If we were in class, of course, you guys would be doing this. I'd have these like paper cutouts for you, or I'd make you cut them out because I should. And then you'd try to fit them together. So I tried to make that same kind of activity, just you're doing it on a screen. So it kind of works. It kind of works. It totally pretty much works. So fit these guys together. And then the next part was, well, why do they fit together? And what does the finished puzzle make you think? And I want you to try to finish those thoughts. And so if you want to do that, you should probably pause right now and go and do that. Go and pause and do those two activities because it won't be nearly as interesting if you continue and listen to me talk about what it meant before you even do it. So pause me. I'll wait. Okay, I totally assume you paused. You did the activity. You wouldn't just keep watching when I told you not to. So this unit is all about this idea. This idea is called continental drift. It's kind of like a Tokyo Drift movie about cars drifting around the sides where they kind of slide around. It's actually very much like that. But instead of cool cars doing it, it's about the continents, about Africa and North America and Australia actually moving around. So the theory states that those continents on Earth, the 7 that we know and love so well, they actually have been moving throughout history and are still moving today. So this unit will be all about you analyzing the evidence for that idea. And all of this evidence actually comes from a guy named Alfred Wegener. It's a W, but he's German, so you could pronounce it Wegener, but he would pronounce it Wegener. Anyway, he published his ideas in 1912, and actually part of your independent work today, so you watch a little bit like animated video about him. It's pretty interesting. I really enjoyed watching it. From the evidence that he saw, he hypothesized that the continents were moving and had once been all connected together. He called this supercontinent Pangaea, which you might have heard before. And actually, is it labeled up here? Yeah, you can kind of see this on this picture, Pangaea, and it's actually labeled down here. So when all the continents were touching to each other, it's called Pangaea, is what he named it. So he died in 1930. And at that time, most serious geologists, people that study the Earth and rocks and the continents and all that stuff, they didn't think he was right. And he was like, this guy's crazy. Because he wasn't, so actually said he was a geologist. He actually wasn't. He was a meteorologist by training. I mean, he studied the weather. Meteorologist. Oh, there's so many O's. Okay. I got that from the video. I didn't actually know that about him. I thought he was a geologist the whole time. So he was not a geologist, but part of his studying the weather, he was like up in balloons. Anyway, you'll hear about it. And he got these ideas from different places. And so those ideas, that evidence that he saw, we're going to be looking at together. And it really wasn't until the 1960s, like decades after he died, and not that long ago, we're talking about like 55 years ago, when the scientific community actually was like, yeah, that actually makes sense. That's a good idea. That's actually probably what happened. And they started to accept this idea of continental drift, which is kind of a really basic understanding of how the Earth works. Now we realize this. We teach it to middle schoolers. You know, I mean, like it's not like some really specific thing that you'll learn in college that maybe doesn't apply to very much. This is like a really basic idea of how the Earth works, and it took a long time for people to believe him and really go, oh yeah, you're right. So real quick, there's more than this. This is kind of a summary of the evidence for continental drift, and there's four real kind of categories. Again, you might see lists of 5 or 6 because you could break things off. So the shape of the continents, we saw that. The distribution of fossils and rocks, we saw that. You also learn a little bit more about that in the video today and other videos. Tomorrow, Thursday, we'll look at the seafloor spreading. We'll talk a little bit about satellites. Actually, now look at this picture. We got satellites orbiting around the Earth all the time, and they can actually measure the continents moving. It's pretty cool. So that's that for now. And for your independent work, I want you to do 2 things. So there's just 2 slides. The first slide is watch a video. So you're going to click on this. You're going to open the link. There's a video here. It's actually also on YouTube, but I like this because it's in Spanish if you like. You could click on this and you can watch it in Spanish. So you can click here and watch it. Oh, sorry. Yeah. Okay. And then I want you to answer these 3 questions. When did Alfred Wegener? Alfred Wegener was a meteorologist. Where and how did he travel? Kind of the first couple minutes of the video talks about this. It talks a little bit about why some scientists believed his idea of continental drift, while others didn't. So which scientists did and which didn't, and why did or did they not? And then it talks a lot about Alfred Wegener. The people narrating the video really like him. So do you agree with them? Do you also like him, or why? Or did you think like this guy seems kind of boring or what? I'm just kind of curious. I didn't know much about him. Earth science is not my expertise, so I'm learning some of these details that I don't ever remember being taught. And so I kind of thought this guy was pretty cool, cooler than I thought I would think that he was. Finally, I want you guys to use the summary table here. We saw 2 pieces of evidence today. We saw puzzle pieces and we saw fossil patterns. And I want you to tell me, what did you see? So you're going to say something like the puzzle pieces fit together. The continents are like puzzle pieces that fit together. Boom. What is this idea evidence for? Think back to the idea of Pangea. Go and look at some of those ideas of continental drift and talk to me about this. We also saw some patterns of fossils. We saw them in a picture like this. We also saw them in the colors of your puzzle. What did you see? Something maybe about fossils on different continents. And what is the evidence for? Again, these might be very similar, but that's okay because there's supposed to be evidence for a very similar idea. So I want you to just keep track of the evidence on this table. And that'll be it for today. Stay tuned. Make sure you check out class tomorrow. The Google Classroom, rather, for something we're going to post. And I'll see you in class on Thursday. Bye.